everyone. Welcome. We're starting off like a series. It's called Inside Eigen. We want to take you behind the scenes of some of our product building that our engineers and engineering managers are doing. We're going to talk about a few things about EigenCloud. Today we'll talk a little bit about Eigen Compute, and for that I wanted to welcome and introduce Madhur, who's our engineering manager running Eigen Compute. Welcome, Madhur.
Thank you. I'm glad to be here and glad to be sharing some cool stuff we have been building.
What will be great is if you can demonstrate what should be the end user experience or even like a product experience for Eigen Compute.
Yeah.
What does it bring to the table? I hear, for example, that it brings verifiable builds. It brings a counterparty risk elimination. What are some things over there that you can talk about? Would love to actually, if you can take us through the new UX that we have. Would love to see.
Would love to share something which we have in pipeline. Let me share my screen and then we can go from there. What we are building here is Eigen Compute dashboard, which will show you all the applications which a developer has deployed. So this is really a place where a user of the app can come and see what the application developer has actually deployed. So for example, you can see this page which has multiple apps, and let's go to one of the apps to see, as this is a running app, let's go to this app and see what we can see here. So it shows like basic things where we have like name, who created this application, what is the application ID. And there are a bunch of things which we can go deeper into related to this application. For example, you see on the right, we have this nice little circle which shows a bunch of properties which we will eventually enable for application developers to look into. Is there anything specific, Vishnu, you want me to go to?
No, I think that looks pretty exciting. So tell me about what does a verifiable build actually mean and how that actually works under the covers.
Yeah, I think one of the things we want to enable for our users is how they can track what is deployed from code to the actual application which a developer is promising you to deploy. We are working on this thing called verifiable builds, where user can actually see here what code has actually been deployed under this URL. So for example, there are two different things you can see here. One is release history. So every release, every update which an application developer does is on chain. So it's on smart contracts. So you can see that, hey, this application developer deployed this release on November 15th, and this is the Docker image which it deployed. So once we have the verifiable build feature, a user should be able to see what is the code which is behind this build. So you can actually map from this Docker image to the code, which proves that, yeah, this is the code we are running. And how to know that this code is actually running in the hardware, and that's where the attestations come into picture. So as we are using trusted execution environment and we are using Intel TDX, you can actually see that, hey, this is the Docker image which got deployed in Intel TDX hardware. If you go inside this JWT, this is provided by the hardware itself, and you can see a signature in the end which is signed by that head. This is the actual stuff which is deployed. So basically you get the hardware attestation of what Docker image is deployed, and then with verifiable builds feature, you can map that image to the actual source code.
Now, let me ask you, is there an equivalent like this in Web 2 where every build has to go through a public verification process of this kind? It's on chain. Is there even like a Web 2 system where you get these properties?
I don't think so. Right now, anything you see, let's say you go to Airbnb.com, under the hood, what is running, you don't know when it's updated, what the new code changes are. But with this, you can actually see that somebody updated from November 15th to November 14th, November 15th, somebody updated this code. So you can know actually when the new upgrade went in.
No, this is pretty amazing all the way. Like think of like CI/CD on a blockchain. That's pretty exciting.
Yeah.
To bring trust into the system. Tell me more about, because the way I understand it, there is no way that a developer can squeeze in an update without it being visible here. And there's also some kind of restriction around timing-based restriction around how frequently that happens and what process undergoes that verification. So tell me more about how.
I think upgrade delay is a very unique feature, and it's kind of uniquely suited for our use case, where a user of an app can actually see that developer has enabled upgrade delay, that when it deploys to when it actually get deployed on the application website, there is some sort of timing delay. Let's say a developer chooses 1 day or like 2 days, whatever they can. But then this gives an ability for user to, if they don't like the upgrade and they're like, hey, I don't want to be on this platform because of XYZ reasons, they have that time to get out of the application they don't want to use. Or like if they have, for example, if it's an agent and they put some money for the agent and they don't like the upgrade, they can just get it out quickly. And then upgrade delay really helps in that front.
I guess another thing you can think about is the agent, but anything that has user identity, accounts, data, anything that is owned by the user, which is what we talk about with blockchains. Users own their own data, and this is one way where you can make sure the user is actually owning it.
And one of the interesting thing about it is if there is a feature which actually deletes user data from the application, it's transparently visible, and you have that upgrade delay that if you don't like, you can delete your data, and because of verifiable builds that, hey, this is the code which is running, which can tell you if you're actually deleting the data or not. All these cool verifications you can do when everything is transparent.
Now, tell me one more thing. What if in traditional Web 2 systems, you could have like a SaaS provider just vanish from the scene because they had some sort of a compliance enforcement or something like bankruptcy, those kind of things going on. So how does this system make sure that the software lives on beyond a single counterparty or a single company having issues? For example, I'll just make this up. Let's say you go to a travel website and you have a lot of your travel history, all of that there. For some reason, that company has gone bankrupt, but you still want to use the services that software provides. I don't think there's a way to do it in Web 2.
If Expedia goes down. So a very good question. I think that's one of the core features we want to enable is like, even though a platform which is hosting this goes down, you can recover your application state and data. One of the things we do is every application gets a unique seed which is only available to that application, and this is powered by a decentralized KMS which bunch of node operator runs, and they come together to generate that unique seed. So it's not only one particular node operator which has access to it, but multiple operators come together and generate the keys. One of the things you can do with that key is you can encrypt your data and store it on data availability systems like EigenDA. And then if the node operator which is hosting goes down, these multiple set of key management node operators which is releasing the secret are still available. So you can still decrypt those data and run this application somewhere else. Now your data is encrypted and stored somewhere like EigenDA, and your code is already on chain, your Docker image is already on chain. So bringing those two together, even if the one particular operator goes down, you can resurrect. And also, since you have unique key, you can encrypt the data, so nobody can actually look into your data. So it has really good privacy properties too.
I seriously cannot think of any Web 2 systems that can give you both the resurrection ability as well as reducing your counterparty risk on any one operator of a system, having full control of what's actually running. So you put the control back into the users in this case.
And then like if some particular platform goes down, if users want to resurrect it, they can resurrect it and still use the platform.
That's pretty resilient, and it's great to see that these kind of applications. And let me ask you mentioned about Docker containers. Now, is there any project in crypto that allows for this level of programmability that you know of and providing all these feature sets?
Not that I know of right now. I mean, this is some unique novel concepts which we are trying to build, and then we have a lot of cool ideas which eventually we will like ship step by step.
Well, thanks Madhur for showcasing the product. So it's pretty exciting to see the journey and how people can leverage it both from a Web 2 and a Web 3 standpoint. So thanks so much for taking us through this.
Thanks Vishnu for asking these amazing questions.